So if we want to draw a graph where we raise our function to the power of some integer, and we're talking positive integers here, then obviously greater than 1, because if the power was 1, not exactly a hard one to draw. Yes. So the first thing, if we have a look at the actual derivative then, so we bring down the power, lower the power to the inside. So again, our stationary points will still be stationary points at those x values. I mean, the y value will change, because we know that f dash x is equal to 0, so in our new derivative, f dash x is still equal to 0. But any x-intercept will become a stationary point, because on the original graph, function x will equal 0. So now in our derivative, that will equal 0. So stationary points will still be stationary points. As I say, the x value will change. Now, if you raise a number bigger than 1 to a power, it's going to get bigger. Smaller than 1, it's going to get... Oh, he said smaller, and then he's gone, hang on, let me think about that. Now you are right, because half squared would be a quarter. So, okay, yeah. So all right, let's say we're going to square this. So my stationary point, well, the maximum will go up higher. Got to be careful though, because obviously when you square it, it's going to become positive as well. So the stationary point here, well, it'll get closer to the x-axis, but it'll now be a positive number rather than a negative number. And so as I say, it's the x-axis, so those x-intercepts will still be x-intercepts, but they will become stationary points. In this case, because it's function x squared, it would have to be a turning point, because it can't go negative. The vertical asymptote will stay, because if it's not in the domain of the original, well, I can't all of a sudden square it and, oh, I get a result. The horizontal asymptote, well, on my example there, the horizontal one is smaller than 1. So when I square that, it'll go smaller again. All right, this is basically what I was saying before about a number bigger than 1, smaller than 1. So, and again, I'm just talking about magnitude here. But if the function value is bigger than 1, then the new curve will be bigger than the old curve. If it's less than 1, then it'll go underneath it, it'll be smaller. So 1 obviously again is a key point. 1 squared is 1. So let's plot with the 1's in, and negative 1 will become positive 1. Right, so we know the curve's going through all that. So now I can draw it in. So below 1, so it goes under the curve. Above 1, so it goes above the curve. So 1 obviously it crosses over. Here's a bit hard to tell with the negative, because of course it's gone positive. But once we get into the positives, below 1, so the new curve is below the curve. Above 1, so the new curve is above. And we just keep doing that all the way along, and we get that very interesting graph there. Now, if n is an even number, then the curve's always going to be positive. So just like the one we just drew. But of course, if it's odd, then the sign will stay the same. So let's do the same curve, but this time let's cube it instead of squaring it. So if I cube it, well, there we go. There's our turning points. But again, it'll go higher for the maximum one. The minimum one will go closer to the x-axis. But this time, these x-intercepts, they're still going to be stationary points. But we're not going to have turning points this time. We're going to have horizontal points of inflection. This shouldn't be a surprise, because if we go back to our polynomials idea, remember we said the x-intercepts act like the root itself? So we're saying this is a curve cubed. So the root should act like a cube, because every factor is going to be cubed. Now, our horizontal asymptote, again, that'll go closer to the x-axis. Vertical asymptote, that's going to stay there. 1 cubes 1, negative 1 cubes negative 1. And again, I can use the idea of below the curve and above the curve. But this time, when I go through those x-intercepts, it's going to be, well, I'm going to attempt anyway, to draw a horizontal point of inflection. Well, I said attempt. It got a little bit dodgy there. But that's sort of what I was attempting to do as I drew that graph. And, oh my goodness, there it is. Very dodgy. Okay, so there's powers.